Ryan is still awesome.
That's right. Ryan Craig is still awesome. Now that you know my name, we're talking about quotient rule for radicals, which is very similar to what you would have seen for the product rule for radicals. That's right. Put your hand over your mouth. You can't even believe what you just said. See, now the quotient rule for radicals looks a lot like the product rule, except we're talking about quotients. And when we talk about this, in order for us to do anything neat, we have to understand that these guys have to have the same index. If you don't have the same index, you can't actually do this quotient rule for radicals. And this quotient rule will allow you to make one larger radical with the quotient of these radicands on the inside. So you'd have the nth root of a over b. I mean, even on the quiz that we took on Friday, and you see the problem on the board, you see something like this. You see the square root of 100 over 49. Now, even though we didn't have the quotient rule to use, we already knew how to work with that. Because when we did this problem, you guys, in your mind, if not on your paper, rewrote this as the square root of 100 times the square root of 49. That's what you did, and that's even how I showed you on the board how we simplify this. And so you guys just give me the answer, 10 over 7. Right?
That's correct.
As long as we all know, as long as we all know our squares, and we've made a list of our squares because we're good, decent human beings. Some of us, anyway.
I have a question.
Go for it.
Is there a reason why you capitalize the A and the B? Is that supposed to signify?
No, I could have used lowercase a and b.
Oh.
That's just, I think it's habit. It's how I've been doing it for years.
Okay.
And he's copying his paper.
We feared change. Oh yes, and because you know, you guys are the reason why they stopped recording in front of live studio audiences and they started using laugh tracks. Just so you know. Why must I suffer with you?
Because we're awesome.
No, only Dylan, evidently.
Thank you for clarifying.
Remember, everyone who exalts themselves will be humbled, but he who humbles himself shall be exalted.
Yes. Preach on, brother. Preach on.
Don't get me started. We're gonna have a good day. We're gonna have a great day. I'm gonna have a great day, especially when you guys are gone.
Mr. Craig, dang, you started taking some compliments.
Now, let's look at this. In the blue example, we split this up as a quotient, one radical over another. In this one, I'm giving you two radicals, but I want you to combine this into one before you do any simplifying. You just gotta trust me on this. Some of you are giving me the look like, Mr. Craig, I don't ever trust you. But you know what? One of these days you will. One of these days, many years from now, maybe you'll look back and say, you know what? I should have trusted him. If I make one large radical with all of this stuff on the inside, that's going to be the square root of 98 x to the 7th y to the 15th over 72 x to the 11th y to the 3rd. Now the reason I wanted to make one large radical here was so that I could simplify. What can I do with this fraction on the inside? How do I simplify this? And really, simplifying here is going back to 0308, going back to beginning algebra. Going from two radicals to a single radical like this is this section. This is intermediate algebra. By doing the reducing is not. How do I reduce 98 and 72?
By 2.
Reduce them by a common factor of 2, so what do I have? Seriously, you know what? Tell you what, I'm trying to get them to answer, but they just aren't, so I'm going to do everything. 98 divided by 2. I'm just going to pretend they're not here. It's just you watching out in YouTube land. 98 reduces by a factor of 2 to give you 49, and 72 reduces by that same factor of 2 to give you 36. Do you guys have any questions? I can't hear you. Good. See, that's what's good about just teaching to people that I don't ever see. And then I look at the variable components, and I will reduce those according to 0308 methods. Where do I have more factors of x, in the numerator or denominator? In the denominator, how many more factors of x do you have? I have 4. And your factors of y, where do you have more of those?
Top.
How many? I have 12 more y's in the numerator. Do you agree?
That the answer is correct?
This is not my answer. This is just the simplified form.
Yes.
Yeah, I was about to say, we should have reduced it more, right?
I can't reduce this more. 49 and 36 have no common factors. 49 is made up of 7 times 7. 36 is made up of 2's and 3's. They have nothing in common. Now what I can do is this. If I take this numerator right here and I do the square root, what's the square root of 49?
7.
And what's the square root of 36? Now worry about your exponents. I've got y to the 12th inside a square root. Remember, this has an index of 2. So make your life easy. How does it break down?
Y is 6. Y to the 6th.
Y to the 6th, and then you're going to have x squared in the denominator. Do you all agree?
Mm-hmm.
Some people will try to tell me that 49 over 36 itself breaks down to 7 over 6. Just so that we make a little note here. Please note that 49 over 36 does not equal 7 over 6. No. What we have here is that when I have the square root of 49 over 36, well, that means the square root of 49 over the square root of 36, and that equals 7 over 6. That's how we get the 7 over 6. A lot of times we get our minds are so set on working with squares inside of a square root that when there's not a square root, we still try to break that down. But you can only reduce it, like we have 98 over 72, you can reduce that because 2 goes into both of them. But nothing goes into 49 and 36. You guys agree with that? All right. Let me do one more. And this is going to be using the product rule. And I show this to you just so you see, I always like putting problems like this on a test. We used the product rule before to kind of split up and to simplify some more complicated looking radicals. We find a perfect square that was inside, we pull that out. But in this example, I'm not going to be pulling things out of here. What I want to do is I want to take this and create one large radical, and then we're going to simplify from there. But there's something you need to know about simplifying a radical or an expression like this. When I make one large radical, don't actually multiply the coefficients. Don't do 10 times 15 and get 150. It's going to be in your best interest to leave them as 10 times 15. Because think about what would happen. If you were to write that as 150, what would you have to do with that guy to simplify? You would have to break it down using a factor tree, right? Why would you multiply to get a larger number that you then have to break down? If you keep this broken down as 10 times 15, you don't have to see the large number and you don't have to freak out. Now what I would suggest you do is that when you have the variable factors is to combine those exponents. So how much x do I have?
11.
X to the 11th, and how much y?
18.
And the reason I combine these guys is because working with exponents inside radicals is really easy to do. Now, since I already have the 10 times 15 broken down as 10 times 15, I need to look for perfect squares. But to do that, I need to factor this guy. How can you factor the 10? 2 times 5, what about the 15? 3 times 5. Now, when we talked about these guys last week, we said that to break something out of a square root, you had to have a perfect square, or you had to have what?
2 of the same number.
2 of the same number. Do I have 2 of the same number?
Yes.
I have 2 factors of 5. So these 2 factors of 5 will give me what on the outside?
The fifth root.
They give you a 5 on the outside, right? 2 factors of 5 inside of a square root is only going to give you 1 factor of 5 on the outside. Bless you.
Thank you.
I'm going to have a factor of 2 and a factor of 3 left over, right? Where do they go?
To the inside?
And what do they look like inside the radical? You multiply and you're just going to get 6, right? Now, leave some space for the x's and y's you need to bring out. And so inside the radical, I'm going to have 6. Now, what about the x's? How much x do I get to pull out? Why 5?
Because that's going to be even 10. Then
Right, because really I'm looking at this as an index of 2. 2 goes into 11. 5 times with how many left over? I get 1x left over. Do I need to write the exponent of 1?
No.
No. If you want to, just as a reminder that it was your remainder, that's okay. What about your y's? I get y to the 9th with how many y's left inside?
none.
I don't have any y's left inside.